In previous slides, we have shown how to do partial fraction decomposition on a rational function px over qx with linear factors, repeated and not repeated, in qx, or quadratic factors in qx. What happens if we have an improper rational function? In an improper rational function, the degree of px is greater than or equal to the degree of qx. We need to divide qx into px such that the rational function can now be expressed as fx equals to sx plus rx over qx, where sx and rx are polynomials and rx is the remainder. Let us try evaluating this integral. Here, the degree of px is greater than or equal to the degree of qx. Thus, we have an improper rational function. First step to take is to divide px by qx. As can be seen, sx equals x minus 2 and rx equals negative 18. This is the product after long division. There are two integrals. The first integral, involving sx, is easy to integrate. But the second integral needs to be decomposed further as two partial fractions. Qx has repeated linear factors. 18 over x cubed minus 3x squared equals 18 over x squared times x minus 3. If we treat qx as having repeated linear factors, the term in partial fraction decomposition can be written as 18 over x squared times x minus 3 is equal to a over x plus b over x squared plus c over x minus 3. However, if we treat qx as having a linear factor and a quadratic factor, the term in partial fraction decomposition can be written as 18 over x squared times x minus 3 is equal to ax plus b over x squared plus c over x minus 3. So, solving for a and b in the first set, by setting the numerators, a equals negative 2, b equals negative 6, and c equals 2. Now, we are ready to integrate. Integrating term by term, the answer is x squared divided by 2 plus 2 natural log x minus 6 over x minus 2 natural log x minus 3 plus a constant c. You may try this question on your own. The suggested solution is given at the bottom of the slide.